Hello. In this session, we will cover AWS Identity and Access Management for our S3 buckets, but this time, instead of using an EC2 instance, we focus on a managed service account. Let's take a quick peek on what this session will entail today. First, we are going to review some of the IAM settings and how it affects our service accounts. We will run a setup of buckets, users, and other artifacts, and then test these with Control M and see how a workflow would utilize the special accounts based on the managed service account. In our fictitious company called Red Cycles, we have two teams, the marketing team and the sales team. They want to exchange data with each other. In the EC2 based session, we covered in detail on how they can do this. But this time we want to add additional orchestration based on the data that either the marketing or the sales team is utilizing. And therefore we need a managed service account that has access to these resources and only to these resources. In addition, we don't want to use an EC2 instance in order to facilitate access to these resources. So that is our fictitious company and the scenario that we are going to implement. So again, just as a quick review, on one side we have to focus on the identity that we are utilizing to authenticate against the AWS infrastructure. And on the other hand, we have the authorization to manage on what kind of buckets and what kind of folders or objects can we access. So we have in our identity and access management really two components. It is the identity that need to be authenticated as well as the authorization against the different resources. Now, with IAM, we are able to really control the access to these resources in services to a level of detail that we don't have when we just use user ID and password for a resource. So we're looking at 6 different areas here. First of all, take a look on how we govern access to these different resources, what is the concept behind, and then actually do the implementation of resources, users, roles, and policies, and see then at the end when we bring it all together how that affects our data-driven execution. So let's take a look at our governance section. What do we need to have? So we need to have first an AWS account that has proper permissions to create all the artifacts. We need to have, of course, Control M in place with access to these resources to create connection profiles, folders, and jobs. And we're going to utilize primarily the CLIs of each of these platforms. So the AWS CLI as well as the Control M automation API to accomplish this task. Now, why are we doing this? Why are we using not the GUI and just focus on the APIs? It's because I'm thinking in terms of automation and orchestration. How can I repeat the process? How can I easily create resources, remove them, things of that nature? I hope that makes sense to you. So let's drill into a little bit about identity and access management and what we need. From this definition, we can see here that there's an aspect of the role that we have, which contains 2 different areas. One would be a trust policy. Who can assume the role? A next property would be the permission policy. And we can ask the question, when I assume that role, what additional resources can I access, or what kind of permissions is being granted to me? So let's break it down a little bit. The trust policies that are defined and they define and control which principals and can assume the role based on the specified condition. Trust policies are used to prevent the misuse of IAM roles by unauthorized or unintended entities. And the permissions policies, they define what the principal who assumes that role is allowed to consume and to access. Really, really important to note here that you want to remember. When you assume a role that will inherit a role's permission, at the same time as we inherit this, we are giving up all the roles and permissions that we are having. So we cannot inherit or hand over the permissions that we have and accumulate more and more permissions as we assume different roles. So the current permissions that you have, they will be done away with. You forget about everything, and only the permissions that are designed by the trust and the permissions policy will be applied. So if we were to summarize this for the IAM role that we need to create our managed service account, this one needs to, of course, have access to the AWS temporary token service that we can create access to these resources. So we have a role identified that is going to be utilized for that user. And in addition, we are having a dedicated policy that defines what resources we can access to. Now, someone could combine the two, could put the permissions to the different resources also on the role, but for our scenario that we have in connection with the EC2 instance scenario, we want to reuse and utilize some of the content that we have built. So for this reason, we have the role and we have the policy as two different entities or objects that is going to be utilized by our managed service account. How does it affect Control M? Well, in Control M, we have the connection profile. In that connection profile, we need to identify three different things. First, we need to have the access key and the secure key in order to authenticate ourselves against AWS. You might recall in the EC2-based authentication method, it is the EC2 instance that has these permissions already, and therefore the Control M agent would inherit this. But here, we have no EC2 instance, therefore we need to have security in place that allows us to authenticate against AWS. Next, once we authenticate against AWS IAM, we want to make sure that we can utilize a specific role. For this reason, the connection profile needs to have the role arm of the role that we want to assume. Now, as you can see here, as the animation was running through, the connection profile utilizes the managed service accounts to authenticate itself against AWS, and this managed service account has no permission whatsoever. Then we tell it, utilize a specific role, and based on the role as well as on the policy, we can identify what roles we can switch into and what resources we can access. So these three things to keep in mind for the centralized connection profile. It is the access key, the secret access key, and the role arm. And you can see here how that is now different from the EC2-based integration, because with EC2, we don't need to have an access key. We don't need to have a secret access key, because that's all handled by the EC2 instance. So accessing resources via an EC2 instance and inheriting these credentials is a little bit safer, but makes our administrative activities more, because now we have to manage an EC2 instance. And in this case, the scenario that we look at today, we don't need to have an EC2 instance. So we're going to walk through the same steps as we did with the EC2 demonstration. I would like to have access to an S3 bucket. The connection profile provides the role arm, the access key, and the secret access key. And in this case, instead of going to the EC2 instance, we are utilizing the managed service account and tell it this managed service account should use now a different role. And based on our roles that we have defined, we can now access and resources and switch our roles. So here's really important, the difference between the EC2 based and the AWS one. It's the service that we are utilizing right now. The service is AWS, and before it was EC2. So we have our role permissions and what roles we can have. And now we are taking a look at the policies. The policies define what kind of resources we can access to. And in this case, we want to access marketing, sales, and the shared folder. And for these resources, for these roles that we created in the other demonstration, we're reusing the role for the S3 buckets as well as for IAM so that we can benefit from this. So once it runs through these different stages, at the end, we have then access to the S3 bucket. So that's the overall process as it flows through the different steps. Now let's take a look on how we then put this into practice. At this point, you can pause the video and review some of the material that is around governance of AWS resources. And these this kind of information you find on the docs pages of AWS or in training material. Keep in mind, this is not a replacement for an AWS training. And so we focus here really on how we can utilize these different artifacts with the view of managing this with Control M. So the first step is going to be, let's create our resources that we need to have. And so keep it very simple with our scenario. We need to have buckets, 3 different buckets: sales, marketing, and share. And we're going to utilize the AWS CLI to do this. Topics you want to keep in mind is you need to know what an ARN is. You need to take a look at the AWS S3 APIs to create buckets. And we are using here also an API to copy a file just to test if we can get over there. So let's get started. Let's create our buckets. We have a script here. And by the way, this is the same script that we used also in the other demonstration. It's now going to create the buckets for us. So as this is running through and creating the buckets, we can take a look at our AWS environment. And there we see we currently have no buckets that are related to our project. And I will fast forward the video with the bucket creation. Pause it here for a second. Okay, all our 3 buckets are being created. Let's take a look and refresh. Here we have our bucket. Just for demonstration purposes, let's take a look. Here's our bucket. We have a folder created just to test if we can access the bucket, and the default settings for the bucket apply. So nothing special on the bucket side. So let's go back. What have we done? We created 3 different buckets with the default permission for our AWS environment. We keep track of the ARN as we need this later in the execution. So now that we have the buckets created, let's take a look at the users that we need to configure. And again, you can pause this video and review how you create resources in AWS, specifically the buckets, either with the web interface or with the API. Now, when we take a look at the users, we know that we have 3 different users, as we had in the other example: the sales, the marketing team, that they can access their resources. We had a shared account that we utilize for the different teams, but we introduced now a different user, which is our managed service account. And this managed service account will not have any permissions whatsoever. What are we going to utilize? Again, the AWS CLI in order to create these artifacts. There are a few calls that we make. You can see them here on the screen. The most important one is to create the user, and then we want to create an access key, because we need to have the secret access key and the access key for later authenticating our managed service account. And of course, let's put the users in some groups and manage the groups. So let's go over to our script environment. And in this round, we want to create the users. Now it's going to create a user. We go and do the same thing here. Take a look at the users. Okay, there's already the first user being created. This is relatively fast to create the user account. And after the user account is being created, we need to have the access key. So you can see this being executed here in a second, that we can retrieve the keys from the particular user. And again, there's a little pause in between of the API calls, because AWS works in an asynchronous fashion, and we need to kind of wait before these objects are synchronized within the AWS management plane. We see here we have now the access key that we retrieve from the users, and also tag the user, exporting that information into a file. And again, we will fast forward in the video to save some time. Now we have our 3 users, or actually our 4 users generated. Let's take a look again at our AWS console. You can see here we have our marketing, sales, and shared user, as well as the admin user, and the admin user is our managed service account. So let's take a look at the permission. There's no specific permission assigned. It's associated with a group and has tags. and that's about it. What we want to keep track of is the ARN of the user, as well as the access key that it was being created, and you can create this access key, a second access key with the web interface or with the GUI. And remember, here we're using the API to accomplish this one. So let's take a look on what we review quickly what we have done. We created 4 different user accounts. One of them is for our orchestration, our managed service account. Okay, so after we have now the user defined, go and review how you can create users with the web or with the API, and specifically focus on the secure access key, as this is being utilized with the connection profile. You may pause the video here and review that material. And again, you can find it on AWS documentation pages. So we have resources, we have users. Guess what next comes? Our roles, because now we need to identify now what kind of permission can this particular managed service account obtain. We have the trust policy associated, which can define on who can assume the IAM role, and we have the permission policy that identifies or helps us to see what does this role allow you to have, what kind of access to have once you assume that role. That is what we're going to create in here. We again use the automation API, the AWS CLI in order to do this. Topics for you to review and take a look at is the assume role, specifically in connection with the STS service, the trust policies, as well as the permission policy of a role, and the API call that we are using here is to create a role. So let's see that in practice. Again, we are going to utilize our script and in this case create the different roles. While this one is starting, let me go over to the AWS IAM section, switch over to roles. And there we can see we have already 2 roles being assigned. And you see here that is running in the background and updating the content. And again, I will pause the video and let it run through, and then we take a look at the details. Okay, so we have the roles defined here. Let's go back to our AWS console, refresh this one here. And now you need to keep in mind, with our integration for EC2, we created a role dedicated to EC2. In this case, we don't need it. So we have a role here that focuses on IAM. So let's open this one up, take a look at the permissions. And as you can see here, the permissions are empty. You might want to refresh here once in a while if you are reusing the same definitions, as the web sometimes has here some changes in there. Now here's something really, really interesting that I have noticed. You see here we have our principal, now AWS, and then we have a string in here. This one will not allow us to properly work with that in the background. So let's see if that refreshes this one, because we need to have a different value in here. We need to have the ARN of our managed service account in here. So let's take a look on how we can accomplish this one. So I go back to my roles. Okay, let's take a look at our user. There's our admin user, there's our managed service account. This is the ARN of the user. We just copied this one over. We go back to roles and edit the role, go into the trust relationship, edit the trust policy, and instead of having this value in there, we need to have the ARN in here. Once in a while, when the script is running in the background, I tested this like 100 times, it has the right value in there, and sometimes for whatever reason, I haven't figured out yet why, it doesn't have the ARN in there. So I can delete it and rerun it again, but this is a very good example for you to troubleshoot. If you happen to have there a different value in there that doesn't match, we need to watch out. So let's click here on update the policy. So the key piece to keep in mind, and this is where we can see the difference between the EC2 IAM role and the one that we have for switching the role without an EC2 instance. Here our principle is based on AWS, and we put in the ARN of the user, in this case our managed service account. So if we were to switch over and take a look at the, just for fun, take a look at the role for EC2 that was being created, you see the EC2 has also here already some interesting values, but this is of interest. You see this one here is now the service that we have in here that allows us to attach it to the EC2 instance. So we don't want to use that. So this is why it's very, very important that you have here in the IAM role that is being utilized without an EC2 instance, that you have the principal and AWS in there with the proper ARM. Okay, so let's review what we have touched on, creating the different roles that we have in place. So we have our roles for the different users that we assigned, but we added a special role for the managed service account. And in that managed service account, we only need to create the role and have the proper ARN in there. There's no need for us to do anything special. In the other video regarding EC2, you can see how we had some additional information within our role, but here just keep it very simple. It's the ARN of the managed service account that goes in there. Okay, so having said that, you may pause the video and take a look at roles, how you create them via the web or via the API. But next we are going to touch on policies. And so here in policies, we really want to keep in mind that there is the entitlement that we have, as well as the permissions that will be assigned to it. So when we create the policies, we have one policy in place for utilizing the AWS STS service, and then other policies that require some additional information regarding accessing the buckets. And again, we're using the CLI for that, and the APIs that you want to review is the create policy and attach role to the policy. We need to have the hook between the policy and the roles and making this happen. Oops. And let's go and create our policies. And again, as that video is running through, I will fast forward the video. Okay, policies are being created. Let's review our AWS console. We go on policies. So there we review, click on the refresh button. We have now the policies for our buckets, marketing, sales, and shared. Then this one here is the STS policies. As you can see here, this is for our EC2 instance. Now let's take a look at the roles and the policy in more detail. So let's open this one up for marketing. And here in our JSON, again, the same that we applied in the other scenario, just to make it complete. This portion here on the top is so that we can have it user-friendly in the Control M UI to list all the buckets that we have. We could also remove this section, and then we need to be very precise when we create our jobs and folders accessing these resources. But this portion here in the bottom is telling the policy now what resources can you access. And in this case, we have the marketing and the shared folder. And because we need more than just root level to see that the bucket is there in the root folder, we need to also have subdirectory access. This is where you see here the /* in our definition. So this gives us access to the marketing and the shared folder. And here comes now the interesting part is, who can utilize this policy? In the animation that we had earlier, we talked about that we have a role, and in the role we have really two components in there, and we said, we are not putting any permissions within the role, we have a policy, and they both will be linked. So the policy is driving the access to the resources, and by means of the link to the role that they attach with each other, now the person who is assuming that role can then utilize that policy. That is what you can see here. This is the policy that is responsible for our managed service account. And then we have in here as well as access to the S3 resources. Now let's go and summarize what we have touched on. We created the resources, the S3 buckets, we created the user, the marketing, the sales, the shared, as well as the managed service account. Managed service account, no access whatsoever. Then we created roles for marketing, for sales, for shared, as well as for the managed service account. The managed service account role gets then, by means of the policies that we created, the right permissions to our resources. And now we bring it all together and want to take a look on how that works with the AWS workflows. And again, what we need to keep in mind here from a governance perspective is that we need to have the access key ID, we need to have the secret key, and we need to have the role on in order to configure the centralized connection profile with Control M properly. So why don't we take a look at that and create these different resources. We skipped a step with associating the policies and the roles to our EC2 instance, because guess what? We don't have an EC2 instance. We can just directly assign the different roles to our managed service account. So that's why we kind of skipped a step that we had in the other video. So now we're going to create our API, or we're going to create a connection profile by means our automation API. So let's do that. First of all, let's take a look at Control M and our connection profiles. So here we have a connection profile from the last run. Let's take a look at that. It contains our access key and the secure ID, as well as the role that we need to have. And here you see it's the control access IAM role that we want to execute. So let's do that. It's our CTM script to create the connection profiles. But in this case, we don't need to create the S3. We don't need to create the IAM4 EC2. So we need to create here the connection profile that is using the managed service account. And in this scenario, we're not utilizing any security. Better to say, we don't use any Control M secrets that we used in the other video. And the connection profile is deployed and works properly. We copied the file over, or we copied the file into our environment here. So let's take a look on executing this one. We run a test, and guess what? We have here our EC2 instance. Would that execute on the EC2 instance? Let's try and find out. So here, the EC2 instance has an agent installed that could inherit IAM roles, but in this case, we just ignore it. We override it and say, use the role and use my keys that I have, even if that is an agent that is running in an EC2 instance. But the most important test is coming if we pick a machine that is not running in AWS. So these other agents that we have in here, this one, for example, the Enterprise Manager, this agent has no EC2 understanding whatsoever because it's not running on that platform. So we can authenticate against AWS. So the first hurdle that we were testing is, yes, we can authenticate properly against that system and we can change the role. Now let's switch over and execute this one as a flow. So here we have in our planning domain prepared a folder that is executing. Let's highlight a few things in this folder. Here we are moving file from an SFTP over to AWS. You see here the connection profile that we are using. This is the one with the IAM role. We have a bucket in the marketing bucket and we want to move a file over. And keep in mind here, this is running on an agent that has no AWS configuration in the backend whatsoever. Next step is we move the file up into our bucket. Now we're moving it down into a local file system and we're deleting the AWS resources to make space there. We clean it up and then we do a directory listing of both environments, the local file system as well as our AWS S3 bucket. Let's run this and take a look at our monitoring domain. And there we have our demo up and running. Here in the output of our pre-flight check, we see which environment we are going to run into. This is running on the Enterprise Manager, and some details regarding the sample file that we upload. Yes, we have a sample file. This is an evaluation of our business logic, and the interesting part is coming here, where we move the file up into the S3 bucket and create a directory first. So you see here, first we're going to create a folder or directory on the S3 bucket, in air quotes, and then we move the file over. And you see here the transfer was successful. And two things to highlight: it's the connection profile that has our IAM role, and it runs on the agent that has no details about AWS, and the account that we are going to use that was specified in this was our managed service account. Next stage of our flow is the other way around. So we are downloading the file from AWS into the local file system. We're deleting the file over on the AWS environment, and then here in the bottom you see we do a directory listing of the resources. Now if we were to take a look at our S3 environment and click here on our marketing bucket, let's refresh to have the latest objects. There's our marketing bucket, and in here let's refresh the page. There you see this is our folder that we generated, matches the smart order ID, and there is no file in there because the download deleted the file. So if we summarize what we have done so far, we have created all the different artifacts to properly run a data pipeline, or to run some content that is based off a file that is on an S3 bucket without using an AWS EC2 instance, and by utilizing a managed service account. So that means for you, for demonstration purposes, you don't need to use your BMC account in order to create buckets or have access to buckets. You can create a managed service account, and by means of the roles that we have, it can run through the different scenarios and access the data properly. And here you see an example of an execution when we are stitching together the managed file transfer component, moving a file from one location to another with subsequent orchestration. That was the purpose of Red Cycles, that we have the two teams, marketing as well as sales. They both have data, but something is in the data that is of importance, and only our data processing will extract that data and then represent that data back to the team. This is what we can see here running in the background. And that will conclude our video for today. Questions that you might have, feel free to reach out to the community and review that video. Thank you for your attention.